Welcome to the last section on our trip, Working with Common Patterns in Akka. In the previous section, we have introduced Akka HTTP module, and we have worked with the client-side and server-side APIs, and also implemented REST API and test cases for it. In the last section of our course, we will take a look at some of the common patterns on Akka, such as balancing workload across nodes, throttling messages, shutdown patterns, ordered termination, and finally, scheduling periodic messages. Let's start with balancing workload across nodes in this first video. In this video, first, we will quickly go through balancing the dispatcher. Then, we will take an overview on the pattern. And finally, we will check the implementation. Let's revise the balancing dispatcher router, which we saw in one of the previous sections. Balancing router dispatches a message to an actor only when that actor would otherwise be idle. And of course, we remember all our actors shared with the mailbox. If we want to distribute work over remote actors, you can't use balancing dispatcher because every actor on each node has a different mailbox. So, if you want to use balance work with remote actors, you should use the work pulling pattern, which has been described first by Derek Wyatt. Let's take a quick overview before checking the implementation. We will have a master actor that will coordinate work, and have some of the workers that will execute the work, and these workers work on different nodes. The main goal is to implement the main fundamental concept of balancing dispatcher with remote actors. So, when the requester actor sends a message to our master, the master doesn't route this message immediately to any workers. The master will wait until one of the workers sends a request to work. So, let's assume worker 1 on node 1 finishes his work, and it will be idle. So it will send a message to the master to request a new work. The master will send a work to this worker. When worker 1 finishes this work, it will send work done intimation. This is the main idea of this pattern, but in order for the pattern to be valid, we must have concrete instances of the master on some node and the workers on the same node or other nodes. And when the worker starts working, it must identify itself to the master. So, each worker must know the location of his master, and the master must be running before the workers try to register with it. Now, let's check the basic implementation of this pattern. Here is the protocol between master and worker. These are the messages from a worker created, worker request work, and work is done. And these are the messages from master to worker work to be done, work is ready, and no work to be done. Here is the implementation of the master. We have workers variable that holds all workers and the work they may perform on it. And we have works queued that represents the received work. And here is the notify worker method that is responsible for sending work is ready message for each worker, if the master has work on the queue. Here is the implementation for receive. When master receives the worker created message, it should have a watch on the new worker and then add it to workers and call the notify workers method. When it receives the worker requests work message, it should check whether this worker is present on its workers. Then, if the work queue is empty, it will send no work to be done to this worker. But, if the work queue isn't empty and this worker doesn't have a work, it will dequeue a work from the work queue, assign this work for the worker, and send it to this worker. When it receives the work done, it will check whether this worker is present on its workers or not. If this worker doesn't exist, it will log. And if it contains on the workers, it will update the assigned work. When the receive has terminated, it will check whether the terminated worker has work or not. If it was working on something, the master will send this work for himself, and then the master will remove this worker and unwatch it. Anything else will add it on work queue and notify all workers. Here is the implementation of the worker. We implemented worker as an abstract class because we should implement the doWork method that executes the actual work. The worker takes the master path on the constructor, and here to take actor ref for master from actor path. In the pre-start method, it will send worker created to the master. Our worker has two states, which are working and idle. In the working mode, we will ignore any message except work complete, which is sent by the worker itself when he finishes its work. When it is received, the worker will send work is done and worker request work to the master and switch itself to idle mode. In the idle mode, when the worker receives the work is ready message from the master, it will send worker request work to the master. And when the worker receives work to be done, we will call the do work method and switch it to the working mode. If it receives no work to be done, we will ignore it. That is the basic implementation for this pattern. At the end of the video, we express balancing workload across node patterns. You can check all details for this pattern from here. See you in the next pattern, throttling messages.